Hello and welcome to the ICS 103 programming course, and today we're going to be talking about two-dimensional arrays. Okay, so basically two-dimensional array is also called a 2D array, and in this class we'll be basically talking about declaration of 2D arrays, accessing the 2D arrays elements, and initialization of 2D arrays, and processing 2D arrays. So let's start. So as you can see in the picture that is shown over here, a 2D array is nothing but an arrangement of anything into rows and columns. And as the name suggests, the 2D array in C, basically, it's a contiguous collection of variables. Okay, so it's a contiguous collection of variables of the same type, just like the 1D array. It can be only of the same type. 2D array is the same thing. The only difference between a 1D array and a 2D array is that the 2D array has two dimensions, so it has rows and columns. As you can see, these are columns and these are rows. Okay, and in the rows and columns, you can actually enter data, and all of the elements of the array are just like the 1D array, are same elements as an integer or a double of whatever you have declared them. Okay. So you can actually view it as a table consisting of rows and columns. So you have the rows over here, and you have the columns that are over here. And to reference an element in the array, for example, this one's table 1, 3. So you go to the row number 1 and column number 3. So the first one is always referred to the row, and the second one is always referred to the column. Okay, so table 1, 3, that means go to the row number 3. So you go to, row number 1, and then 3 is the column, so this is the third column, and the intersection, if I may do it, so you have to go to row number 1, so you basically go from here to here, and then column number 3, so you go over here, and the intersection of both is, this is the element that is going to be selected. Okay, so this is how it basically works. So the same reason that necessitates the use of 1D array can be extended to 2D array. Sometimes you'd like to arrange the data in a two-dimensional array rather than a one-dimensional array, and you want the same data to be contiguous. Okay, for example, to store the grades of 30 students in 5 courses require multiple 1D arrays, or you can have a single 2D array with 5 columns. Okay, this idea can be easily extended to other higher dimensions, so you can have 2 dimensions, 3 dimensions, 4 dimensions, whatever you want. The 2 dimension is a table, the 3 dimension will become a cube, and then you can grow onto those other dimensions. We will focus only on 2D arrays. Okay, so in this class we only go to 2D arrays. We will not take you more than that. Okay, so how do you declare a 2D array? So 2D array variables is declared by specifying the type of elements. So first of all, you have to specify the type. So for example, over here we have the type int. Okay, then you have to specify for me the name. So table, for example, is the name of the variable that you're going to be declaring. And then for 2D arrays, you have to specify between square brackets 2 numbers. The one is the first dimension and the second one is the second dimension. Or equivalently, this is the number of rows and this is the number of columns. Okay, so you have to specify for me the number of rows and the number of columns so that I can actually allocate this memory into the allocate this much space into the memory, and it has to be consecutive memories. Okay, both rows and columns are indexed from 0. Okay, so again, as was the case with the 1D array, you have to start with an index of 0 in the rows and an index of 0 in the columns. So if you have an example such as this, so you have 3 rows and 4 columns. This is a 3 by 4 array, so this is 3 by 4, as you can see. 1, 2, 3 rows and 1, 2, 3, 4 column, all of them starting with an index of 0. Both the rows and the columns start with index 0. The rows goes from 0 to the size specified -1, so 3 minus 1 is 2, and the column starts from 0 to the size -1. The size that was specified was 4, so 4 minus 1. Okay, so as we saw in the 1D array, it's a good practice to declare the size as a constant. So you can say hash define rows to be 3 and hash define columns to be 4, and then you can define in table rows and columns. Now rows will take the value of 3 and the columns will take the value of 4, so you will have exactly this one in your memory. So this is actually a representation in the memory. There is nothing called a table, it's all sequential. Okay, And this is again table 1, 3 is over here. If I want to have table 1, 1, that will be 1 and 1, the intersection. This is the element that is table 1, 1. 0, 0 is the first element of the array. And going on, you can index all the elements of the array. So now I want to access, okay? So we want to enter, as the program was saying over here, we want to enter one room or one element of the array. How would we do that, okay? So basically what we do, we type the name and then the row index and the column index. When we type the name, the row index, and the column index, it will give us specifically that element. So if we define int table 3, 4, and we want to access the element 1, 3, and put 64 in it, so we say table 1, 3 from this table is going to be 64. So what's going to happen is we're going to go to the rows. We're going to go to the first row and to the third column, because this is specifies 1 and 3. And in the intersection, this is the element of the intersection. And inside over here, we're going to write 64. This is what's happening when we are actually doing this, or when we execute this command. So it goes and writes 64 in row 1 and 3. We use the same format to refer to an element in an expression. So you can actually say table 2, 3 is equal to table 1, 3 plus 2. So in this case, now going back to our laser, to our pen, sorry. So we have table 2, 3. So we go to 2 and 3. So this is the element that we are talking about. Okay, this will equal to the value of table 1, 3. So the table 1, 3 is 64. So the value that is stored over here is 64 plus 2. So this will have a 66. Okay, so the value of 66 will be written in this element, because we said that root 2, 3 is equal to this expression. So you can actually use it as a normal variable. You can assign value to it, and you can actually use it in an expression. Okay, going on. Initialization of a 2D array. Okay, so as with 1D array, the same way, if we already have the values to assign to the array at the point of declaration, we can declare and initialize the 2D array at the same time. Okay, how do we do that? This is an example. So in this example, we say table 3 and 4. So we have a table that has 3 rows and 4 columns, just as you can see in the example, 3 rows and 4 columns. And these are the values that are going to go. So the first, so there are, notice there are big curly brackets and the outer curly brackets, and there are inner curly brackets. So each one represents a row. So there are 3 rows, and each row has 1, 2, 3, 4. So 1, 2, 3, 4 numbers, and these numbers will be copied inside over here. Okay, and the second will go to the second row, and going on, the third one will actually be filled to the third row. Okay, so this is what's going on. So you take the numbers and you put them inside the row. Now, as was explained in the 1D array, if you provide less values than the declare size, so if you say 3 and 4, and you only provide 2 values for here, example, you don't provide 4, the rest will take the value of zeros, okay? So you can also declare int table and do not specify the first dimension of the array, but you have to specify the second dimension of the array. So as a rule, whenever you're working with this 2-dimensional array, the second dimension is always specified. So you always specify the second dimension, okay? No matter what you do in C, the second dimension has to be always specified. The first dimension, you have the right, okay? So you can actually say that I don't want to show this. I'm not going to give you this one, but I'm going to give you the other one, the second dimension. And then you can specify, and this will be okay because these are 3 rows and each row having 4 columns, okay? And the value will be assigned, so the compiler is going to count how many rows are there and automatically going to assign this value. But this is wrong. This is not allowed in C. This, let me put an X over here, it cannot be done. You always have to specify the second row. Although you're telling it over here that you have 3 rows and 4 columns, you did not specify this, so this is going to generate an error for you. This is wrong. Okay, so do not do this. actually what you have to do is this. If you have the values, or what you can do is specify everything from start. You can specify the rows and columns and give the values, so you have the choice of deleting the rows but not the columns. Okay, please make sure that you always specify the columns. Okay, I cannot stress on this more. So processing 2D arrays. To process a 2D array, we need to use nested loops. Okay, so in the 1D array we use 1 loops, and the 2D array we'll have to use 2 loops. Okay, 1 loop for each dimension basically. In 3D arrays we'll have to use 3 loops. In 4D arrays we'll have to use 4 loops. So at each dimension you have to have a loop. You can access an array element row-wise or column-wise. Okay, so this is, for example, the array. We can actually show it as stack boxes next to each other, and you want to access this element, you can access them either row-wise or column-wise. So here's an example. If we say for int row index is equal to 0, row index less than rows, and row index plus plus. So we have an integer variable row index, which we assign to 0. Why do we assign it to 0? Because the index actually of a row starts from 0. Okay, so in our example over here, let me go back over here. So the pointer, so this is the row, it's going to start 0, 1, 2, and this is the column, which is going to start 0, 1, 2. Okay, so this is the row and this is the column. Okay, and in this for loop, now let me flip back to this. In this for loop, we say the row index starts from 0, which is from here, and then the row index is less than the number of rows, and this is the constant that we have defined. In this case, it will be 3. We can process the row, so the row elements can be processed. Okay, so you can take the entire row and process the elements. But processing a row involves processing each element in the row. So in the row, as you can see, each row has 3 columns in our example. Okay, and if you define an array that is of bigger size, you might have bigger row size, bigger columns. So you might have 5, 7, 8, depending on the example that you have. But in our example, we have 3. So now to go into this one by one, we have to have 2 for loops. One for the row. So this is going on the row. So the row index going from 0 to and adding 1 and going less than row. So 0, 1, 2. So it's going 0. Then it will go select row 1 and row 2. The second for loop is the column index. We define an int column index is equal to 0, because the column index also starts from 0. It goes to the column index less than the number of columns. In this example is 3, and the column index plus plus, and then you do some work. Now notice what happens over here is, okay, so let's take this example. In this example, we have int row index. So we have actually row index as a variable. Okay, and then we have it starting at 0. Okay, so we start at 0. It is less than the number of rows, so we go in, we find another for loop, and in it we define a column index. Okay, and in the column index we also started with 0, and since column index is less than 3 in our example, which is less than 3, then we actually go in and we can actually now over here, if we say let's say that the command that is over here process the element of a row array. Let's call this well, whatever. So the index that we are working with will be row and column. So this is the row. So this is the row index. This is the column index. Let me just delete this again. Hold on. So now over here, what we have array, row index, and column index. So the row index is 0, column index is 0, 0, and 0. We are at element number 1. Now, once we finish with this for loop and go back, we have to increment the column index by 1. So the column index will go from 0. This will be deleted and will become 1. Okay? When it becomes 1, we're going to go and we're now indexing row index. We're indexing the second number over here. Okay? Then we are going to increment the column index by 1. So this 1 is going to become 2. And then we are referencing this index. Then we're going to increment this by 1. This is going to become 3. And when it's 3, basically, this condition will become false because this is 3 in our example. And when this 3 becomes false, we go back to the row index and we increment this by 1. And when we come back in, notice we'll go from 0, 1, 2, and 3 again. So we're going this, this, and this. Then we are going to come out of this for loop and go back to the row index for loop. And then when we come back, we're going to go through this, this, and this is going to be false. And then this will become false, so this will go 0, 1, 2, and then once 3, we're going to get out of here. So notice how we moved. We moved in the element here. This was the first one. Then we moved here. Then we moved here. Then we shifted from this element here. Then we shifted here. Then here. Then we're going this way. This is how we work row-wise. Okay? So when you have the row index on the outer loop and the column index in the inner loop, this is how you go. You go row-wise. You go 1. You start jumping from here in the row. And then the second one. Then the third one. Okay, so this is basically how you work when the row index is out and the column index is the inner. In the other example over here, when you're processing 2D arrays, you can actually go column-wise. In the column-wise, what you do is the outer loop, you make it a column index. So the outer loop will go 0, and inside it, the inner loop will go 0, 1, 2, 3. Then it will come. So this is the column index, and this is the row index. So I'm just gonna make it smaller like this. So the column index will go 0, 1, and inside it the row index will go from 0 till 3, and then over here again 0, 1, 2, 3, then 1, 2, it will become 0, 1, 2, 3. So the column, notice the column is staying the same value for a very long time. So basically you're going to go from here and then jump over here, then jump over here, and from here you're going to go jump over here, then jump over here, then jump over here, based on what the rows and columns are doing, and then you're going to jump over here. You can actually follow this one at a time if you have any problems, or you can ask me questions later on. But this is how you are changing. So the column stays constant for a very long time, whereas the row, as you can see, since it's inside the inner for loop, it's going to be changing faster than the columns, and that's why you're going to go row-wise in this, not column-wise, okay? Oh, you're going to go, sorry, column-wise in this, and not row-wise. In the previous example, we went row-wise because the outer loop was not the column, it was the row, and the inner loop was the column, okay? So this is how you work with an array. Let's take an example. So now we want to read two matrices from the user and add them. So this is what we want to do. We want to two matrices and we want to add two matrices together. So to do this, we have our hash include and we define our rows to be 10 and columns to be 10. Notice that your array has to be of a fixed size. You cannot have an array that is having an floating size. It has to be fixed, so that the compiler can go and allocate the memory. And we over here said I, j are two variables, and we have A, rows and columns. So this is a two-dimensional array that is of size 10 and 10. B is another array that's size 10 and 10. C is another array that's size 10 and 10. And notice that we initialize the first element to 0. That means all the elements of the arrays will be initialized to 0, because if one is initialized and the others are not initialized, the others will take the value of zeros, and we define rows and columns, okay? So now we ask the user to enter number of rows of a matrix 1, and we read those from the user, okay? So he'll say, how many rows do you want? And the user will enter a number, and we read it into the rows. Then we ask the user, how many columns are inside your array? The user will enter a number and we'll save it inside the columns. Now we have in the rows and the columns, how many rows and columns does the user actually want, okay? Now notice those rows and columns, the values that they are going to enter has to be less than 10, okay? So it has to be less than the values that we specify over here. Otherwise, we're going to have a problem. We're going to go outside of our array, and that is not allowed. Well, C doesn't check for it. You can go actually outside. There is no bound checking, but you're going to have a very odd behavior, as you will see in the lab if you work on it, okay? So then we say enter %d, which is the row, elements of matrix 1, row-wise. So row multiplied by column, so the number of rows. So if he enters, for example, 2 and 2, so 2 by 2 is 4. We ask him to be entering 4 elements in a row-wise manner. Okay, and then we come over here and say for I is equal to 0, I less than row. Okay, so notice the row has been entered by the user. So we're going to read only those numbers that the user wants. How many rows is there? And then there's a j for j is equal to 0 and j less than columns, which is the columns that the user wants. Okay, not the 10 and 10. Okay, it's what the user has input, and we're going to read the input. So if he said we have a 2 by 2 matrix, we're going to be actually reading 4 elements, which will be 0, 0, 0, 1, 1, 0, 1, 1. Okay, so those are the elements that we're going to read, and we're going to be assigning them to the array A. So you might have array A that is of size 10 by 10. Oops. Okay, and you might be, so it's 0 to 9 and 0 to 9. Okay, and this is the variable A. Then you will have a variable B, similarly a 10 by 10 array. Okay, and it's going to be 0, 1 going on until 9 and 0, 1 going on until 9. And then you have the same thing, you have another array. Okay, we just extend this. So it's going to 0, 1 going on until 9, 0, 1 going on until 9, and this is C and this is B. Okay, and you have rows and columns. These will be variables. We can actually put them here, row and column. Okay, so this is basically your arrays, and this is what the user is going to input. So let's take an example of what the user. So we ask the user to enter number of rows. He says 3. The example is 3 over here. Enter number of columns, and he said 3. So we are working on a 3 by 3 matrix. Okay, then so the user entered over here 3, so the row will be 3, and the column is 3, so because the user entered over here 3. Then we're going to tell him enter 3 by 3, that's 9 elements row-wise, okay? So suppose that the user enters 1, 2, 3, 4, 5, 6, 7, 8, 9. What's going to happen? These are going to be using these for loops, and I am actually putting it into the address of aij. So I am going to be putting it 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so notice over here, I have worked with a partially filled array, and we're going to be talking about it later on. So we are working only on this array. The user wants me to work on a 3 by 3 array, so I'm going to take it over here. Then I'm going to ask him to enter another row into column matrix, because we have to add 2 matrices. So he has to give me 2 matrices so I can add them. And this time, notice, I'm going to store it into B. So if the user enters 9, 8, 7, 6, 5, 4, 3, 2, 1. So this will be 9, 8, 7, 6, 5, 4, 3, 2, 1. And these are the 3 elements of our array. Okay. So after this, we're going to continue on the next page. When we're adding, we say for I is equal to 0, I less than row, I plus plus. So we're moving row-wise. And j is equal to 0, j less than column. Cij is equal to aij plus bij. So what's going to do is going to take the first element and add it to the first element. 1 plus 9 is 10. Then it's going to go increment I by 1, increment j by 1. So I will stay constant. So it's going to be 2 plus 8 is going to be 10. And then it's going to go 3 plus 7. It's going to be 10 again. And it's going to start filling this 10, 10, 10, 10, 10, 10. Okay? So now C, after this execution, will have the 3 elements of 10, 10, 10, 10. Then you have to print this to the user so the user knows what's the addition. So for the printing again, you first print the sum matrices. So the sum matrices will be printed to it. And then using the 2 for loops, you print the Cij now. The Cij will print 10, 10, 10, 10, 10, 10, 10, 10, 10. Okay, so notice the print /n is outside this for. So whenever you finish printing a complete row, you're going to put a slash n over here, and then going to start printing another row and put a slash n, and then print another row and put a slash n, okay? That is why it's in 3 lines. Then you can actually get out of here and your program actually stops over here. Okay, so this is how you basically work with 2D arrays. There are many examples on 2D arrays. I'm going to stop over here, and I will hope to see you in the next class. Thank you. Bye-bye.